One of the programming languages taught here at the Tech Academy is Python. Python is a versatile language with many uses. We put together this video to give people a taste of how things are taught at the Tech Academy and how anyone can learn programming. In this video, we'll make a very basic text-based game in Python. In section 1, I'll define all the terms you need to know in order to help you through this video. And in section 2, we're going to walk you through the process of downloading Python. And in section 3, we're going to create a very basic text-based game using Python. After completing this video, if you're interested in pursuing more at the Tech Academy, please visit us at learncodinganywhere.com. Once again, that's learncodinganywhere.com. All right, here we go.
Section 1, Basic Terms. High-level language, a computer programming language that is designed to be easy for people to read and write. High-level languages look somewhat like English, and the words used have similar meanings to what they mean in normal conversation. Example, code written as follows would be high-level language. Print hello. You are telling the computer to write out the word hello. Low-level language, a programming language that is designed to be easy for a computer to execute. This is called low-level language because it is brought close down to the computer's level of understanding. A person attempting to read a low-level language may become confused, because the lower the language, the less it is like English. Example, most people find that a low-level language is more difficult to learn than a high-level language. It can look like this, MOVAL61H. Here you are telling the computer to put a number in a specific location in the computer's memory. Scripting. Scripting is creating a series of commands that cause your computer to automatically perform actions. Example, you can use scripting to make a web page automatically play a video when people go to that page. Scripting language. The origin of this term is similar to its meaning in a movie. A script tells the actors what to do. In programming, a script tells the computer what to do, step by step, in order to accomplish a specific task or tasks. A scripting language is a programming language used to make scripts. Often, the tasks these scripts accomplish are valuable to automate, so that the task steps don't have to be entered into the computer again every time you want to do those tasks. In principle, any programming language can be a scripting language, because you can write a script for the computer using any programming language you can understand and operate on. In practice, there are programming languages that are better than others for making scripts. These are what is meant by scripting languages. Scripting languages are high-level languages, meaning it is easier for people to understand and read scripting languages than other highly technical programming languages. Example, if you wanted to make it so that every night at midnight a list was printed off of all the people who signed up for your school classes in the previous day, you could use a scripting language to make a computer script to do so. Compiler. When you write code to make a program, you usually write it in a form that looks almost like English. For example, it might look like, if age greater than 18, then print you are an adult. Computers can't understand language like that, so that code would have to be changed into a form that the computer does understand. A compiler is a special program that converts the code that looks nearly English into a form that the computer can understand and operate off of. The product of a compiler would be a set of instructions understandable to the computer that the computer would execute. This would make the computer do what the nearly English code described. Example, you type, if age greater than 18, then print you are an adult. A compiler would take what you wrote, change it into a very low-level language the computer can understand, and then relay that command to the computer so it will be executed. One important aspect of how a compiler works is that it takes all of the instructions in the program and turns them all into language the computer can understand before executing the program. There are other methods of converting high-level language to machine-readable language that don't involve converting the entire program before it is executed. IDE. This stands for Integrated Development Environment. An IDE is a set of programming tools for writing software programs. IDEs are a great aid to software program development. An IDE often combines many available tools into one place. Things like a text editor, a compiler, a display of the file structure of the files in your software program, etc. Example, Visual Studio is an IDE created by Microsoft. Interpreter. An interpreter is a special program similar to a compiler in that it converts high-level language instructions into low-level language instructions. The difference between a compiler and an interpreter is that an interpreter performs this action one instruction at a time, rather than converting the entire set of instructions in the program prior to execution. In other words, the interpreter will read an instruction, convert it to low-level language, Have the computer execute that instruction, then go on to the next instruction in the program and repeat. Example: interpreters are used in scripting languages. Interpreted languages use interpreters, not compilers. Object. In the world around you, you are surrounded by objects: your dog, the TV, etc. Objects have state and behavior. The state of an object would be the condition, or state, of its characteristics at any given point in time, its size, color, etc. The state of the object may change over time. A balloon, for instance, will not have the same size after a week that it had when it was first inflated, so you can see that an object's state can change. The behavior of an object is what the object does, the actions it takes. In our example of a balloon, possible behaviors might include inflate, deflate, and pop. In programming, objects are part of computer programs. They share a similarity to real-life objects. They have state and behavior. Example: an application might work with a customer object. The state of an object would be the characteristics and attributes of the object at any point in time. The behavior would be what the object could do. Example: our customer object could have states like active or deleted. It could have behavior like upgrade rewards level or add to family account. Objects are one of the first things you can think about when designing a program. An object could be something on a computer that you can click on, interact with, move around, etc. It could also be something behind the scenes that is made up of data and procedures to manipulate data. An object is what actually runs in the computer. Example: let's say you wanted to make two different types of cars on a computer. Each car would be an object. Each object, car, would have its own size, shape, color, speed, distance it could travel without needing more gas, etc. Object-oriented programming, OOP. There are different approaches you can take to programming. Object-oriented is an approach to programming that focuses on objects and data as opposed to actions or some other approach. The first step in OOP is determining what objects you are going to be dealing with and how all the objects relate to each other. OOP is a popular approach to programming computers that is used in many languages. Example: if you were creating a website using object-oriented programming, you would focus on all the things you want included in the website first: pictures, pages, videos, etc. Then design the basic outline of each type of thing, then on from there, always focusing on the data and objects to be used by and contained in the website. Python, a programming language created in the late 1980s that has the following characteristics. A. Python is a high-level programming language, which means it looks similar to English. B. Python is an object-oriented programming language, which means it focuses more on data and objects as opposed to other approaches. C. Python is an interpreted language, which means it has an interpreter built in, a program which converts the high-level language to low-level instructions the computer can understand. D. Python is a scripting language. One can use Python to make scripts to automate things. Python is considered by many to be one of the easier languages to learn. Python can be used to create apps, programs, websites, games, and many other things. It is a very versatile language with many uses. Python was named after the famous British TV show and movies by the same name, Monty Python. Example: Python is in use in many popular areas. Dropbox.com was created using Python. YouTube, Yahoo, and Google all use some Python for various things, including assisting in searching for things online. Guido van Rossum, a Dutch computer programmer born on 31 January 1956, Guido van Rossum is the inventor of the programming language Python. He was employed by Google from 2005 until 2012, where he spent half his time improving the Python language. In the Python community, van Rossum is known as a benevolent dictator for life, BDFL. BDFL refers to the fact that he continues to oversee the Python development process, making decisions where necessary. IDLE. IDLE stands for Integrated Development Environment, and since van Rossum named Python in honor of the British comedy group Monty Python, the name IDLE was probably chosen partly to honor Eric Idle, one of Monty Python's founding members. IDLE is intended to be a simple development environment suitable for beginners. especially in an educational setting. Example, you could use idle to create a Python program. Variable, the name given to a location in a computer's memory that a program has set aside for use in storing data, in the situation where the value of the data stored in that memory location may change over time. This is useful because as the value in that memory location changes during the program's execution, the programmer has a name to refer to that memory location by. Example, you could create a variable with the name product price. This might be set to the value $10.99 initially, but at some point while the program is running, the value of the variable product price might be changed to $8.99. Assignment. This is the action of giving a value, description, amount, etc. to a variable. In some programming languages, you assign a value to a variable using an equal sign. You are stating that that variable now has a certain characteristic. Example, annual income equals weekly income multiplied by 52. You just assign the variable annual income the value weekly income multiplied by 52. Operator. The word operator is used to classify the different actions that can be done in mathematics. For example, plus and minus are operators. When new actions are defined in computer science, the symbols used to indicate them are called operators. An operator is a symbol that represents an action. Example, in programming, commands like and or are considered operators. Example, if person types both John and Sally, then turn the screen blue. And is an operator. If the person types either Bob or Tom, then turn the screen red. Or is an operator. Other common operators are the mathematical actions for multiply or divide. The symbols used for these operations are usually an asterisk for multiplication and a / for division. Age in months equals age times 12. Price per item equals total price divided by number of items. Function. Work performed by something. A function is an action taken to get something done. In computers, a function is a command put into a computer that makes the computer complete an exact task or series of tasks. A computer function is a procedure the computer performs. There are thousands of functions entered in your computer behind the scenes that instruct your computer on how to operate. Example, when you erase a file on a computer, the file is removed by a delete function. String, a sequence of characters. A string is simply a connected series of letters, numbers, words, symbols, etc. Strings are written by developers when coding as a frequent action. Example, in the computer instruction, print John is smart, the series of characters John is smart would be the string. Call. To call means to demand or direct something. In programming, a call is a direction by a main program to execute the tasks of a subprogram. A subprogram here meaning a smaller program that operates within a program. More specifically, a call is when a program temporarily transfers control of the computer to a subprogram. A program could make many calls to multiple subprograms as the program does its sequence of tasks. Calling is the execution of code. Example, if someone said, call your code, that would mean to run the code you have written thus far. Operand. In math, this is the number that is being dealt with in a mathematical operation. It is not the action being taken with number, it is the number itself. Example, in 5 plus 6, the operands are 5 and 6. The plus sign is the operator. In computing, an operand is the part of a computer instruction which specifies which data is to be manipulated or operated on. This is the data we are doing something with. Elif. This is a type of command in programming that is short for else if. It literally means, if something else besides what I mentioned earlier occurs, do this. Example, if user types yes, continue program. Elif, user does not type yes, close program. Syntax. Every spoken language has a general set of rules for how words and sentences should be structured. These rules are known as the syntax of that particular language. In the programming languages used to program computers, syntax serves the same purpose. Syntax are the rules you must follow when talking to a computer and telling it what to do. There are many languages you can use to program a computer. Each language has its own syntax. Failing to use the syntax of a particular language correctly can mean that whatever you are designing will not work at all. Example, if a computer language required you to write CMD at the beginning of each command, that would be part of the syntax of that language. And if you didn't write CMD at the beginning of a command, the computer would not follow the command because you violated syntax. This would be a syntax error. Section 2. Installing Python.
In this section, we're going to download Python 2.7. I'll walk you through the process. First, we need to download the latest version of Python 2.7 from the official website. So we'll need to go to www.python.org/downloads. We're now on the official website of Python. Now we can download the latest version for Windows 2.7.9. So we're going to go ahead and click on Download Python. And on the bottom left-hand side of your screen, you'll see Python. This roughly takes about 40 seconds to download. Once it's finished, go ahead and click. It's going to bring you up the installation process of Python 2.79. Select whether to install Python for all users on this computer. This is perfectly fine. Go ahead and click Next. Select Destination Directory. By design, Python installs to a directory with a version number embedded, Python version 2.7, so that you can have multiple versions of Python on the same system without conflict. Of course, only one interpreter can be the default application for Python file types. So let's go ahead and click Next. Customize Python. These settings are perfectly fine. Go ahead and click Next. It's going to ask whether or not you want to install this on your system. Go ahead and click Yes. And it's going to go ahead and start to install. This takes a couple minutes. One of the nice things about Python, installing it on a Mac OS X Yosemite, it comes with Python 2.7 right out of the box. Once it's finished downloading, go ahead and click Finish. And we've now successfully downloaded Python. To find it, go ahead and go to your Applications and find Python. Here we are, Python 2.7. We're going to be working in the idle. Go ahead and double-click that, and it brings the shell right up.
Section 3. Making the text-based Python game.
Hello everyone, my name is Dan Christie. The previous instructor just walked you through doing the installation of the Python 2 idle, and now I want to take a moment and help you build your first text-based game. It's called Nicer Main. We're going to be using some key concepts of passing variables from one function to another function. This way that other function has access to that data and can use it. Instead of making you painfully watch me type out my code, I'm just going to go ahead and just cut and paste my code, but then I can discuss my code so you know the logic step by step. Feel free to pause the screen if you need to catch back up, but let's go ahead and begin. Before we get too far into this, I just want to teach you some basics that I think are very important. Everybody should definitely be considering this when they're writing code, and that's this top section here. To do a comment in Python, you would start out with this hashtag. Then that makes your font a little bit different to denote that it's actually a comment. So Python will actually ignore it, but it gives information to whoever's looking at your code, and it could even be you. 10 years from now, you may forget why you did this, what your code was supposed to be doing, and this is your way of conveying that back to you so you quickly know what's going on. So I usually start out by putting the Python version. This is the version I was developing in. This is the version I know that my code works with. Then of course you put down your author. If you're working with a team of authors, it's good to put everybody down, maybe even your email addresses so you guys can get in touch with each other, or someone can get in touch with you and ask some important questions about your code. And then of course put down your purpose. What was the whole intention of this software? What were we supposed to get from it? What's it supposed to do for us? That's pretty important. And then of course comment your code, you know, where it actually fits in and where it's important, where you think you actually need to really explain what your code's doing. And remember, think about the 10-year factor. 10 years from now, when you've actually forgotten this software, you want this to quickly tell you exactly what it was you were doing. So just remember that concept. Down at the very bottom here, this code right here, this if underscore pipe name, if you go down here, if we run this script, Python looks at that line and says, okay, you're running this as a script, so I need to run the next function you have underneath this, and then it will go down to each function in order. So that's important. If you have this in here, you know that this start function, which I put underneath here, is going to be the first function to actually fire off. To test out your code, you want to go up and choose File, save it, then go to Run, and Run Module. Yeah, you can use the hotkeys. I tend to do that a lot. But you can run the module. You'll see the results in this screen. You can actually set up your screen the way you want. This is just how I like to do it, and I think it's probably the best format for the video. So I'm going to go ahead, again, cut and paste some code in here to speed the process up. Feel free to pause it and type it all out and get caught up to see what we're doing. But this way I can go ahead and explain my code without making you wait for me to do all the typing. So right now we're going to start off by passing a variable to the start function. So this function, we'll be calling this function because, again, down at the bottom we are calling start. And in our start function we are using a Python built-in method called print. And print, coincidentally, has this function name that I put in here called getNumber. So getNumber is this function right here, which I am actually taking an integer, number 12. I'm putting that integer, saving it into this placeholder, this variable. This variable is just called number. So 12 is going into number, and then we're returning number to whatever function had called getNumber, which coincidentally is start. So print, we're not printing getNumber, we're printing the results, what's being returned, which is number 12. So let's go ahead and see that in action. There you go. We've got number 12 over here, so that worked. We successfully passed a variable from one function to another function. So let's go ahead, with this basis, this background, let's go ahead and do something a little more advanced and see that in action. So this is another way of, again, doing the same kind of principle. We're going to be passing a variable from one function to another function, but in this case, we're going to use name. And for name, we're going to get the user's name, which we don't know in advance. So we can't just automatically store that in name. We're going to have to use this function here called this raw input. With raw input, we're going to actually inquire from the user for feedback to save their answer into the name and then pass that off. When you're dealing with Python 2, it uses the raw input as a built-in method. If you were doing this in Python 3, when you do this in Python 3, you would actually be just use input. So input is it kind of condensed it down to just being input. Whereas Python 2, they're using raw input. So just understand that there are subtle differences between the two versions. If something isn't behaving the way you thought it should, do some research. That's going to be the golden rule here is research, research, research. In fact, you'll never be done researching in programming. You're going to always run into things that aren't working right or behaving right, or some concepts that are a little more advanced, and you're going to want to know more. So definitely be willing to do a lot of research. All right, so let's see this in action. We're going to go ahead. We're going to ask the user for their name. They're going to give it to us. It's going to store it into the name variable here. Then we're going to return that to start, who's actually inquiring to print it. So here we go. What's your name? Daniel. Bam, it says Daniel. So that's how that's done. We could actually do what's called formatting, which is a way of using wildcards. So I want to show you how that's done. We could go up here where we're doing the print, put in 2 quotes. We're going to put off the word format, and then it's got its own function. So we got to do an open, and then we're going to do a closed like that. Okay, see how it grayed out? That's how you know that you opened it and successfully closed it, because it's graying from the open to the close tag. All right, so this keyword format means whatever variable that I put here, and if I put the placeholder symbol in here, it's going to just substitute. So let's say hello. That squiggly line right here, this chevron going this way, this one going this way, or basically that's the wildcard. So Python saying, okay, all right, when I see that, if you put a variable over here, I'm going to substitute it. We are going to get a variable. It's going to be the return of the name from the user. So let's go ahead and see this in action. All right, what's your name? I'm going to put in Sarah. I'm going to lie. All right. Hello, Sarah. See, so it actually substituted right here the word Sarah because that's what was being returned. Pretty basic, but definitely essential to learn this. All right, let's do one more. This is going to be a little more advanced, but again, important. So in this one, we are actually going to have start be the one to actually contain our variables with the information. So f name is going to have, so that's going to be first name. I like to use naming conventions for my variables to be something that's a little more obvious so I know what it is. Think if you're doing a larger project and you're working, let's say 30 pages in, you don't want to be trying to track what all your variables were standing for. So it's good to kind of use that naming convention. So f name, first name, it's going to be Sarah, last name, Connor, you got age, 28, and then we threw in a gender, female. And then at that point, we're going to call our get name function. Of course, name isn't really good. We could say something more like maybe get info. There we go. Let's change it up. We're changing our code here. Let's put info there. So now we're going to call this function get info. Makes a little more sense. So get info is going to require the first name, the last name, age, and gender. It requires these 4 variables. If it doesn't have this, it's going to give an error. So we have to give it to it in order for this function to work because it's requiring it. So we are saying, all right, we're going to call you and we're going to give you this information because we just so happen to have all that information right here. Get function is going to take those variables in, and we put in a bunch of wildcards. Wildcards work in order. So when Python sees this first one, it's going to fire off this first variable. Sees the second one, fires off the second variable. Third, likewise. Right? So that's how that works. You could put in starting with a 0 index, then the 1, then the 2, then the 3. It will still do this in order just like that over here. So it doesn't really matter if you put the numbers in there. But just so you're aware, you can do that. Maybe it makes it easier for you later on. So there you go. Let's go ahead and save this. Let's see this in action. There you go. So my name is Sarah Connor. I'm a 28-year-old female. Boom. There you go. It used all of our information just like we wanted it to do. So that is it in a nutshell. And we're going to be using that concept as we go to do this particular game. So let's go ahead and start off with that. Again, I start with the start function. So I'll just get us back to that. I'm putting in nice as a variable. It requires mean as a variable, and it requires name as a variable. And if you notice, I have an equal sign and a value. This is default. So if this function start is not being provided nice, it's not being provided mean, it's not being provided name, it won't necessarily get upset and give us an error because I gave it default values to use in the event it wasn't provided anything. If you do provide it something, then it will overwrite these defaults with whatever it is you give it. So to start off the game, we're normalizing ourselves. We're initializing. Nice is 0. Mean is 0. Name is empty. We don't know the person's name. They haven't gotten any actual score for the game yet. So we're starting out initialized. So directly below that, I'm going to go and say name. So in order to get this name variable, we need to call the describe game function. And we're actually passing in the name variable. Right now, we have it. It's empty. But eventually, we're going to get the user's name, and that will be given back to us. So we'll have their name, and we can actually address them accordingly. So that's that. I'm going to go ahead, and we're going to do the function for doing the describe game. And when we go to describe the game, basically what we're going to be doing is describing to the user exactly what they can expect to play this game. So there we are. We've got describe game. These three quotes, what's in between it is going to be commenting. You could do this up here with the hashtag. That's generally when you want to comment one line. If you want to comment what they call block quote, that's a lot of lines all at once. That's how you would do it, is using these three. So, and it is a little bit different color. You can adjust that in Python. That's just the color coding I like to use. All right, so there you go. I gave a little description. Here's what the user, or here's where our logic, so what's going to happen. We're saying if our name isn't empty, then we have their name and we can actually address them accordingly. That's why we have the wildcard here. Then at that point, we're going to do a loop. And we're going to give, to do this loop, we're going to say stop is equal to true. Then the next line is the while loop. And we're saying while stop. So basically, stop is true. So we're saying while true. We're going to continue to do this over and over and over again until we set it to false. At that point, it will stop doing its loop. I don't want to set it to false until the user has actually satisfied my question. If they haven't satisfied it, I'm going to continue to persistently ask this question. So we want to get their name. When you're dealing with user input, it's a good idea to control it, to initialize it, to actually normalize it into a format that you can actually use. So I'm going to do a dot capitalize at the end of this. That's going to take whatever they give us and do a capitalization to it, making it a little more presentable for us to deal with it later. Then at that point, if after we ask the question, if the reply isn't empty, we can go ahead and address them accordingly right here. And then we can go ahead again, set stop to false to stop the loop. So basically, to figure out what it is we're going to do next is, if you have a function that you called in here, that should probably be the next thing you write down so you can define that function. In here we don't. So after we do this, name comes back up here. So at the end here, we're returning the name that we just got from the user. Returned it back to here because we called and we said, we're going to give you a name, it's empty, go ahead and do your stuff, give us the name back, and we'll store it and use it. So now the next thing is the nice mean name. We're going to get all three of these variables all defined. We're going to call the nice mean function. And we're going to pass in what we know currently for nice, mean, and name. Currently, we know nice is 0, mean is 0. We now have the user's name, so we can work with that. So let's go ahead. We'll do the nice or mean function here. Let's grab that code. All right, so there's the nice or mean function. Again, we passed in our three variables. Now, nice or mean can have access to these variables and work with them. We're doing another loop. I'm going to hit set stop to true. So while true, we're going to call show score. So that'll be another function we're going to have to lay out here in code so Python knows what's show score function supposed to do. So we again do the raw input. The question in here is, a stranger approaches you for a conversation, will you be nice or mean? And then I put up here N or M so they can see that the type of data we want back is an N for nice, M for mean. And then I put a dot lower at the end, so if they do it as a capital or lowercase, we're still going to get lowercase, which, at that point we can kind of expect the data and know how to work with it. This /n here, /n, that means to go down one line on the screen over here. So this way my text isn't kind of getting all clogged together. We're just going to give it a little space in between. So if whatever the user gives us, if they say no, then at that point we can go ahead and invoke this line of code, and then we can add our 0 currently for nice. We can add 1 to it. Nice will be 1 now. We do it again, 2, 3, and we'll just keep adding it up. Once we add a score like this, we don't need to continue to ask this person this question. So once they give us one or the two of the answers, we'll just set it to false. Then at that point we have our information we needed, and we can pass these three variables to score, and then scores function will do something for us as well. So we'll start off up here with the show score because that was the first function I called, and let's do that. So show score is pretty simple. It's just going to show the score to the user, to the screen. Show score requires nice, mean, and name. Then we have the wildcards, and we're going to use that information to present to the user. The next part that we need to go ahead and do is this right here we call score, passing in nice, mean, and name. So we'll go ahead and do the score. All right, so there's the score. Again, it requires nice, mean, name. What we're going to do is we're going to check nice. We're going to check the value of nice. If it's greater than 5, we call win. So we'll call a win function. So they'll win basically if they have more than 5. Mean, if that goes greater than 5, they lose, and we call the lose function. And again, we pass in our variables accordingly. If it's neither of those, so they didn't lose, they haven't won, the game's still afoot, so we're going to call the nice mean function all over again. That's again going back up here and asking them again if they want to be nice or mean, and then doing the adding of either nice or mean. So the next function that we called here was going to be the win. Right here, nice mean. We got our print function. We're substituting. We've got the variable. And then we're going to call again function, passing over nice and mean. So you kind of see a basic theme here. We are passing variables amongst the functions. This is the best way to do it. You don't want to do doing global variables where you define a variable at the very beginning of your code and then everything has access to it, because you clutter up your namespace, and it's really bad practice. The best way to do it is what we're doing right now, which is to pass the variables from one function to another function, and you have full control of what's happening with that variable. The next function we called was lose, right here, passing in our variables. Passing in our variables, it takes it, go ahead and puts it in place of its wildcards because of the format method that we're using on it. And again, it calls again function. So both of these are calling again function, so that will be our next function to lay down. We're going to pass in our variables. We can see we're going to be doing a loop. So we've got to stop, setting it to true. So while true, we're going to give them a choice, and that's going to be a question. We're going to say, do you want to play again? So they have an opportunity to play this game all over again. Again, data return is going to be lowercase. If their choice is yes, we can stop asking. We can call the reset function and pass in our variables. If the choice is no, we can go ahead and say, hey, see you later, alligator. Let them know that we've acknowledged that they're wanting to they've indicated they want to quit, and at that point we can stop asking the question and we can run an exit method, which is again built in for Python, and we'll exit our game. So if they didn't provide a yes or a no, they obviously didn't understand our question, so we have an else clause, and we're going to print to them, okay, well, Y means yes, N for no. This way maybe they will better understand what it is we're looking for as a response. The last piece of code here is we called reset right there. So at the very beginning, if you look at this code, there's our reset function. If you look at this entire page, you think, wow, there's so much here. I don't know what it's doing. It's very confusing. But as you saw how I kind of went in order, one function is calling another function, calling another function, calling another function. After a while, you start to see how your program flow is working, what the logic's doing, and then it actually makes a lot more sense. And now this all seems like it's not enough code to finally pull off a game. So, all right, so let's look at this. Reset takes in nice, takes in mean, takes in the name. We're going to, so this is if they indicated they want to play again. So if they want to play again, it's the same player. So we're not going to go with their name and erase it. We're going to keep it. So that way we don't have to ask them again. But we are going to, since they're playing the game all over again, we're going to reset back to 0 for nice and for mean. So the score is going to reset, but we're not doing anything with name. We're just going to keep that so we can still continue to talk with them. So the next function we call is start, which again was our start function we started with. This time, instead of name being empty like we told it to do by default, we actually have a value now in here. So name, we've got their name, 0, 0. When we go to call the describe game, in the describe game function, again down here we said, or actually it was right here, in describe game we said, hey, if it's not empty, we already know their name. We can just go ahead and deal with it right then instead of going through all this and asking them the question. And then we're going to go ahead and run it. Now don't be surprised if you get an error. That is the nature of programming. No programmer is going to be able to fire off their code and expect it to work 100% of the time. There's always going to be something to debug. We're human. We mistype. We put characters out of place. Sometimes our logic gets a little fuzzy, and we got to go back in and figure out what it was we were doing, because the program's just going to do exactly faithfully what we told it to do. So we obviously have told it to do something wrong. So that's part of the fun of programming, is going back and debugging your code. Here it is. What's your name? I'll say Daniel. All right, so it's explaining, hey, welcome, Daniel. In this game, you'll be greeted by several different people. You can choose to be nice or mean. At the end of the game, your fate will be influenced from your actions. Then it says, Daniel, you currently have 0 nice and 0 mean points. So it's saying, stranger approaches you. Do you want to be nice or mean? I'm going to say nice. I'm going to say nice for this. And it says, hey, a stranger approaches you, do you want to be nice or mean? So it's asking me again, but it did right here say, Daniel, you currently have 1 nice, 0 mean. So it is actually adding that up. So I'm going to be mean this time. So we should get, a nice, 1 nice point, 1 mean point. Here we go. And yes, sure enough, we have 1 nice and 1 mean point. In fact, I could enlarge this so you can see that happening. We don't need to look at our code right now. Do I want to be nice again? Well, what do you think? Should I win or lose? Let's go ahead. We'll try both functionalities just to make sure. So we're going to do nice. We have 2 nice, 1 mean, 3 nice, 4 nice, 5 nice. Remember what happens after 5? I win. All right, boom. All right, there you go. Nice job, Daniel. You win. Everyone loves you, and you now live in a palace. Do you want to play again? See, that was important. So it is going to our, do we want to play again? So I'm going to say yes. All right, look at that. It reset. And now it kept my name. It said, hey, Daniel, you currently have 0 nice, 0 mean points. Do I want to be nice or mean? Let's be mean this time. All right, 3 mean, 4 mean, 5 mean, and I lose. Too bad. Game over, Daniel. You live in a van by the river, wretched and alone. Let's try N for no. Look at that. See you later, alligator. And then Python, of course, is saying, do you want to quit this program, which we, doesn't really matter if we do or not, because that's the end of the tutorial. So I'm very, very pleased that you wanted to learn with us here at Tech Academy. We've got a really good staff of knowledgeable instructors here. Definitely, please join us. Thank you very much.